Hey everybody, welcome to another episode of RV Tips and Trips. Today we are going to work on our Suburban 12-gallon water heater. It's a combination gas and electric heater, and the problem with it right now is it's giving me no heat in the electric mode only. Works just fine with propane. The idea is to save money and not spend a bunch of money on propane when we are in parks with full hookup. I'd rather use the electric part. So I said the electric part's not working, and we're going to figure out what's going on. We're going to troubleshoot it. Alright, so this is a Suburban 12-gallon water heater. It has an anode, and then there's a heating element, electric heating element right back here. And then this is your gas jet, because this will run on both propane and electric. Now these are reset buttons up here, so if you're getting no heat, you can try those. And right now we have a no heat situation on the electric only. The gas still works. So I've let the hot water tank cool down. It's been off for a long while. This way nothing's hot. So I want to check and make sure that the heating element is okay. And your control switches are behind this panel here, which there's only 2 screws that hold it in place. The left reset button is for the electric, for the 120 volts. The right side one works off the 12 volt system, which activates this valve here to allow gas flow and turns on the igniter, which this is the igniter cable here. So we're going to troubleshoot the 120 volt side of things first, and we're going to make sure the heating element's good and that the control switches are good. I'll see you in a minute here. Right, I've turned all the power switches off. There's a on-off switch down here. That's off. The on-off switch for the electric and both the propane inside the trailer are off. And I turned off the circuit breaker. That's for the water heater only. So this all should be dead, and we should not have any issues. What I will do is measure. Here's the heating element now exposed, the connection part. It's a rod that goes into the tank. Now I did change this the other day, and it worked for a little while. Now this is supposed to be a 1440 watt element. They didn't have a 1440 watt element. They had a 1500 watt element. So only a 60 watt difference. I calculated that it would only be a half amp difference between the two, and that should be okay. It worked for a little while and then stopped working. So either the new heating element failed, and there's different reasons why that could fail. Number one, if there was an air pocket around the heating element, which I doubt, because the heating element's still all the way down at the bottom. So even if this wasn't purged of all air, but if the heating element's not surrounded by water and you turn it on, the heating element will just instantly fry. So not good. So what we want to do is measure the resistance across here and see that it's about 10.5 ohms is what it should read. Shouldn't read 0, and it shouldn't read infinite. So like I said, about 10.5 ohms. So if I do get that, then the heating element is good, and then the problem is elsewhere. So alright, so I have my voltmeter. I'm going to make sure there's no voltage on it. This would be AC volts, and we'll just measure from ground. Here, I'll go to this screw head right over here, to the hot lead, and there's nothing. So it's safe to go ahead and measure across there. So now I'll put this on ohms and put that up there. Short this out and it reads 0. Now I'll measure across the heating element. .3 ohms. Alright, so that's good actually. Should be somewhere around 10. I'm getting 9.3. So the heating element is good. So the problem is elsewhere. So next thing we're going to check out is the thermostat switches back here. Alright, so I got the 2 screws from there removed. Now there is a gasket here to keep water from leaking in. Ooh, that is sealed up there tight. Alright, there you go. Get the cover out of the way. Alright, so what you got here, this side here is for the 120 volts, and this side here is for the 12 volts, which runs the propane. So I'm looking at the wiring. I don't see any burnt wires. See a pine needle there. Alright. Alright, so now what we need to do is measure continuity. There's 2 thermal switches here. This switch here closes at below 130 degrees. So if the water is cold, these contacts are closed. And then the contacts will reopen when you hit 150 degrees, and so this will cycle between 130 and 150 right here. This switch up here is an emergency cutoff switch. It's labeled an ECO, and then it's got this thing on here which is so you can push the reset, and this cuts off at about 180 degrees. So it's a backup to the switch. So like I said, it's supposed to cut off at 150. If the switch is shorted and continues on up, then this one will open at 180 degrees. So this switch here is normally closed. And if that fails, pressure builds up in the tank. And in that case, your pressure relief valve will open at, well, I'm going to measure resistance across these switches and see that they're okay. So flip this back over to ohms. Wow. There we go. This reads infinite. The leads are good. I short across, they read 0. So that switch is no good. The top one is good. So this switch here went bad. So we got to replace this switch. Now these switches are not compatible with these because this is rated for 120 volts. These over here are rated for 12 volts. So I got to get a new thermal switch. Alright, so to remove this assembly, we just remove that nut. These thermal switches just lay flat up against the tank. So remove that nut, pull these plugs off, and then I can pop in the new unit. So easy peasy. Alright, so we're going to remove this. This is a 3/8 inch socket. Fits right on there perfectly. Don't lose the nut. Put that in the tray. And that's it. The power is off, the circuit breaker is off, and everything is off as before. So there is no polarity to these switches. It doesn't matter. These switches are basically wired in series. Okay, come on. Just don't drop the wire behind the thing. Come on off there. What I'm going to do is just, so they don't drop back there, I'm going to go get the part. I'm going to just tape this in place so it doesn't go anywhere on me. Nothing worse than those wires dropping behind. So I'll just temporarily do that. I found a place that has the part. It's like $18, so we're gonna run and get that. But there it is, and this plate just sits right up against the tank, right like that. So this is the bad switch on here, but you got to replace the whole assembly. So, okay, and there's the part number 2306. So that's, you got to make sure you get the right part. 2306 is the part for the 120 volt side of things. Alright, so Amazon does have this part also, and but I needed this a little quicker. You could have it in a couple days from Amazon, but since there's a parts store, RV parts store nearby, I'm just going to go with this. But so you just got to make sure that it says the last four of the part is 2306, because Amazon sells both, the one for the propane side and the electric side, so you got to make sure you got it right. Anyway, this is the original element, heating element out of this, and it is kind of cruddy. It's calcified actually. If you measure across the heating element, it still reads the proper resistance. It read like 10.2 ohms, but I went ahead and just replaced it anyway. That's why I got all nice new parts. This is 1440 watts. I replaced the heating element with a universal one, which was 1500 watts. That's when we found out that we got a bad control switch, which we're going to put in a moment here. So it's real easy. I removed the cover earlier in the video, that cover over here. In order to get this out, you need a special tool. This is the tool. You can get it at like Ace Hardware, Lowe's. It's standard. Use this for hot water heaters on your home heater. Anyway, this fits right on there, but you would have to remove these wires in order to really get this out. Yeah, you're gonna need to remove this, which is what we did. This is the jet, so there's a bolt here, one there, and then use a wrench and unthread the gas connection off, and this just comes right off, and then that gives you plenty of room to work on removing the heater element, and that's what it looks like. You can see this fits right on there like that. Screw it back in and refill your tank. So absolutely make sure you refill that with water, because if you turn on the the electricity to it, and there's no water in the tank, you are going to burn up the heating element, and just like that. So it happens real quick, so don't do that. All right, so there is a new heating element in there, and then we found we had a bad switch. So we're going to replace the switch. Got a new one, and I made the mistake of going to Camping World to get the part because I needed the part right away. So here's the old one, here's the new one. Just remember, there's two types. There's one for the gas side and then one for the electric side. I made sure I got the one for the electric side. The one on the electric side has a part number stamped on here, 2306. So that's what you want. So the control switch operates between 130 degrees, and I said the upper limit to that switch is about 150, so it should average out to about 140 degrees. So that's the new one. So it mounts right on here, right onto the stud. Make sure you got the one with the reset button up, and then these connections are going to go right on here. Matter of fact, before we screw that in place, it's easier to put those wires on. I just taped these down and put so they wouldn't drop off until I got the part. Oh, what I was going to say, I got this at Camping World, this part, and it was very expensive. Let me tell you, 38 bucks, where everywhere else it's like $18. You can get it at Amazon, and Amazon it's under 20 bucks also, and I will put a link in the description for the part. So Camping World's a bit of a rip-off when it comes to this, but if you need the item right away, then I guess that's the route you have to go. Otherwise it takes a few days to get it from Amazon. So I'm making these connections here, being careful not to drop the wire down, so then that would be a pain trying to fish it out. Alright, so connections are made there. Get that on. Get the nut on there. You gotta be careful not to accidentally drop it down there. So these switches are then right up against the tank. So no thermal conductive Vaseline or anything like that, just dry. Oh, there we go. And this was a 3/8. And that's on, and that is it. So now it's just a matter of putting the rest of it back together. But I think before we put it back together, I'm going to test it. So before we get too carried away, I wanted to go ahead and just make sure the switch is good. You never know, you can get a bad part sometimes. But so you measure right across the switch, and it is 0. It goes right to 0. So the other one showed open. When I removed it, then it started to read resistance, which a switch shouldn't read any kind of resistance to it. So it had probably burnt contacts within the switch, real flaky, a resistance connection, and then you may get a low heat situation instead of maybe totally no heat, but low heat because there's resistance in there. So the meter needs to go to right to 0 and not kind of float around. These two switches, the control switch and the ECO switch, they're wired in series with each other. So if either one of these is open, you're going to get no heat. So this works at, like I said, 130 degrees, and then the switch opens back up at like 150 degrees, so it averages out to about 140. The ECO switch, which is the emergency cutoff switch, opens at 180 degrees, so it is normally closed. So if that switch goes bad, you get the same thing, no heat. The pressure relief valve is also a temperature sensor. This opens at like 210 degrees, which is a backup to the ECO switch. So pressure will open it if the pressure exceeds a certain point within the tank. And matter of fact, on the label here it shows 210 degrees Fahrenheit. So it's also temperature dependent. So it's a special pressure relief valve. So you got to make sure if you do ever replace this that you get the correct part. It's a backup to the backup. So we don't need a tank exploding, because if you just superheat the water, accidentally things fail, the tank will explode. Turned on the circuit breaker and the electric switch inside the rig. There's also a switch down here. This switch is also in series with these switches. So right down here, it's kind of hidden. Sometimes people forget about it. Right now I have it off. We're going to turn it on. Now this circuit is live. So I'm going to put my voltmeter to AC volts, and we're going to measure from ground, because you're not going to hear anything heating up. So gee whiz, is it working? We're going to find out. So we go to this side of the switch, and I got 110 volts there, like I should. So I said these are in series with one another. We can go right here to the heating element. Let's see, 118 volts right there at the heating element. So we're good. Alright, so now we're just going to have to wait and see if the tank heats up. And then once that happens, then I'll just put it all back together and we're good to go. Alright, so I have a digital temperature reader. It uses infrared, so we'll go ahead and get a reading right off the tank. See that it's heating up. Gotta get it right. Let me get a good spot there. Oh, there we go. So after a couple minutes, it's reading 106 degrees, 107. So it's heating up. Cool deal. So it works. So I'm going to button it all back up. And then, so today you've learned how to actually troubleshoot and repair the your hot water heater. This is a Suburban hot water heater for the electrical side. Similar process for the gas side. If the gas side of things is not working, you have same kind of deal, 130 degree temperature switch right here, and then an emergency cutoff switch up here. But this is low voltage. This is only 12 volts, and it operates the gas relay down here and the igniter. So same thing, you would measure across these contacts after disconnecting power to see if the switches are closed. If they read open, then you got a problem with the switch. If these are working properly, then you may have a problem with the either the gas supply or the relays down here. So similar process. All right, so that's it for today. Until next time, happy camping. Bye now. Thomas says thanks for watching. Don't forget to subscribe and like and share. Until next time, happy camping.